We are now going to Dr. Mohammed AlTannir for the study design paper.
So here we start. We are going to talk about study design. We all know that the process of research is to really come up with a well-answerable research question and select the study design to answer this research question, write the research proposal in detail, implement everything stated in the research proposal in the actual study, and the findings of my study population will really make inference to the truth in the study, assuring the internal validity that should be really applied. The truth in the study will really make another inference to the truth in the general population, truth in the universe, and by that we really assure the external validity. So we have two kinds of research. We have what we mostly in medical research do, quantitative research, and we have also qualitative research that is mostly applied to social and psychological field. So the research pathway that starts with a well-defined research question and ends by writing a scientific manuscript to be published in a well-known journal. The study design, as you see, it fits almost in the first half. So we have to study to really select the best study design that answer our research question within the cascade of my research pathway. So let's talk about the taxonomy of quantitative research study design. We have to keep in mind one major issue. If me as an investigator will intervene to assigning exposure to the study participants. So if the answer is no, so all what this study fits under observational study. I'm not intervening to assign participants to any group, neither control or study group, but I'm just observing what's happening. So under the observational study, there are two major groups, analytical study group and descriptive study group. How can I really differentiate if my study design is descriptive or analytical group? If I have a comparison group, so my study fits under observation analytical group. If I do not have a comparison group, so my study is just simply observational descriptive study. In the analytical group, I have three different directions. I have the cohort study, the case control study, and the cross-sectional studies. And this really, this study designs are based on the selection of the participants. How do I select the participants for this study? In cohort study, I select my participants based on their exposure, on their risk factor status. So if I do select my participants or patients on their exposure status, so my study design is cohort analytical observational study. If I select my patient based on their disease status, if it's present or not, so my study design is case control analytical observational study. And if I do select my participants, usually for surveys like questionnaires, this is what we call cross-sectional study, because exposure and outcome are collected at the same time, so exposure is not preceding outcome. For cohort study, sometimes we see people really confusing and talking about it, referring to it as prospective or retrospective without really saying it's cohort. Retrospective and prospective are just adjectives for the data collection for the time of data collection. So prospective, that means starting in the present and going into the future to collect the data. And retrospective is starting now and going into the medical file, into the history of the patient to collect the data. So this is from the observational large arm of like study design. If the researcher intervene, that means we are under interventional or experimental study. That could be either randomized or non-randomized. If the patients are randomly assigned to control or study group, we call it randomized controlled trial. If not, we call it non-randomized controlled trial, or we call it also as a convenient, convenient trial. Based on a convenient sample, that means not every patient included or participant included in the trial have equal chance to be selected to the study or to the control group. So this is simply what is quantitative taxonomy of research design is. So it's very important to keep in mind that we have two large arms, experimental or interventional versus observational. In the interventional, we have randomized versus non-randomized. For sure, there is more details about blinding that we'll talk about in a few seconds. And in the observational, we have two major groups, descriptive and analytical. And in the analytical, there is three subgroups, which are cohort, case control, and cross-sectional. So what are the descriptive studies? These studies are concerned only and designed to describe the existing distribution of variables, usually like demographic variables and like other related variables of the study without investigating in the causal or other reasons. The descriptive research, if it's on basis of individual, we call it, if it's on one person, on one patient, we call it case report. On several patients, we call it case series. If it falls on the entire population, we call it ecologic studies. An example of case report is a typical trigeminal neuralgia associated with tongue piercing. So this case happened only on one patient. Case series, when we have more than one, we can have also extended case series that sometimes precede the occurrence of clinical trial and could be up to like tens of patients. In this example, botulism in 4 adults following cosmetic injection with an unlicensed, highly concentrated botulinum preparation. This is a case series example. The ecologic studies are such exposure data for population, outcome data for population. Analytical studies, as we said, we have the observational, the cohort, a group of cases followed over time. It could be followed for several years, observing the incidence of heart attacks in statin users and non-users is an example. As you see here, the exposure is present versus absent, and we will follow up with them to see who will develop the disease and who do not in both groups, in the exposed patients or participants and in the non-exposed participants. And the cohort study will allow me to really measure the incidence of disease. This is the only study design that will allow me to measure the incidence of disease. As I told you, prospective and retrospective is related to the collection, to the time collection of data. Prospective is from present to future. Retrospective, we go from past to present. What are the strengths for cohort studies? It allows me to measure the incidence. I can investigate multiple outcomes. study rare exposure, and it will really assure the temporal sequence to causality between exposure and outcome. The weaknesses: selection bias could be expensive if it's going for a long time, require large sample size, and risk to loss to follow up. The cross-sectional study, prevalence study, this is what we call prevalence study. It allows me to measure the prevalence of a disease, group examine at one point of time, like example, examine a group of patients once observing the prevalence of history of MI in statin users and non-users. So this is a cross-section study. Both groups, exposed and non-exposed, are studied at the same time. The strength is cheap, quick, and it allows me to assess the study to assess a disease prevalence. Weakness: does not establish sequence between exposure and outcome, not feasible for rare exposure or disease, and does not yield incidence or true relative risk of the disease. Case-control studies, sampling based on outcome on the disease status, and then comparing prevalence of exposure in both groups, what we call the odd ratio. Example, examine a group of patients with MI, this is the cases, and compare them with the group of non-MI patient, the control, and track statin use in both groups. This is an example of case control study. So we collect them based on the outcome and not outcome, and we go to see who was exposed and non-exposed between control and study group. So the controls also should be free of the outcome of interest. This is very rigorous. We should select our control rigorously, should be representative of the population and of the population at risk of the outcome, and select independent of the exposure of interest. The weakness of case control study: there is a potential bias for bias and confounding, especially for recall bias, for survivor bias, does not establish sequence of event, does not yield the incidence, rather odd ratio, which is the substitute of the incidence. The strengths: inexpensive, short duration, and very useful for studying rare disease and those with long latency. So we go now to the other arm of the quantitative study design, the randomized control trial. So two groups created by random process. So if we randomly assign patient to receive statins or placebo and then follow both groups for several years to observe the incidence of MI. So randomized trial, this is my sample, assign randomly patients to treatment or placebo group or control group, I can say here, and see in the future who will develop MI or not. The key elements: sampling eligible patient, a selection bias can occur, generation of allocation, confounding by indication can take place. Selection bias also can happen at allocation concealment, blinding or masking, performance bias and measurement bias, and attrition bias if adequate or follow-up could not be really achieved. So the benefits of randomization: it eliminates bias in treatment assignment before and after enrollment. On average, provides balance on factors other than intervention that could influence the outcome, known and unknown, and facilitates the blinding of participants, investigators, and assessors. We mean here data collectors. So permits use of probability theory. Blinding is really important because, and the most used one is double blind, where neither the investigator nor the patient know to which group the patient belongs. And sometimes we are forced to, or we cannot really use the double blindness, and we run what is called open blindness, because blinding could be unethical or not feasible as in surgery field. So the study design also is related to the level of evidence. The best one is good quality randomized controlled trial is class of evidence 1. If it's not very well conducted, the trial, it could fall to group to level 2 of evidence. Good quality observational analytical group like cohort case control falls under class 2 evidence. And case series database or registries corresponds to level 3 of evidence. So the challenge in study design is to really select the study design that best answer my research question, because if not, there is a jeopardy of external validity from the truth in my study to the truth in the universe, like what I found in my study population, to really make solid inferences to the source population. Another issue also how to implement strictly the study proposal in all items, because if not, my internal validity itself, that means the findings of my study will not be valid, and internal validity is shaking. That means if I repeat the study on my study on a similar or same patient, I will get a different finding. So this is very important, these two issues. Select the best study design, implement strictly the study plan are really crucial in order to ensure a good internal and external validity, and my inferences will be more robust. So the study design best depends on the hypothesis being tested, minimizes bias and confounding in order to ensure a good level of evidence, be ethical and feasible. What type of question my study design answer? For therapy, etiology, and prevention, randomized clinical trial is the best study design. For diagnosis, prospective blind comparison to a group standard is the best study design. For prognosis, cohort followed by case control case series would be acceptable study design. And for cost type of research question, economic analysis will be also a good suggested study design. So in conclusion, it is a well-defined research question that dictate the study design. Not that every study should be a randomized clinical trial because it's the gold standard. The proper use of evidence-based information is not the strict adherence to only randomized clinical trial, but more accurately, the informed and effective use of all types of evidence. Thank you so much.